All right, let's find the derivative. Problem with this one is that x is the exponent, right? It's not the base. It's not a polynomial. And it's not base e. What do you think we could use to find this derivative, to get that x out of the exponent? What could we do? So if we take the log of both sides, natural log y equals natural log of 2 to the x power. Since this argument, this exponent, is in the natural log function, we can bring that down in front, right? Natural log y equals x natural log of 2 then. Natural log of 2 is a constant, right? And it's kind of like the coefficient of x. Think about it. We could write it like this, right? I like to leave it like this so it doesn't look like the x is part of the natural log. Okay. Now let's find the derivative. And we use the natural log to rewrite. We didn't do anything with it yet. We use it to rewrite this function or this expression, equation, so we can find the derivative. Okay, the derivative of natural log y would be 1 over y times dy dx, right? Using the chain rule, implicit differentiation. The derivative of the right side, well, that's a constant times x. That's just natural log of 2. Now to solve for dy dx, that'd be y times natural log of 2, and we know what y is, right? Y would be 2 to the x power times natural log of 2. Now, a lot of times we actually write it as natural log of 2 in parentheses times 2 to the x power. A lot of times we'll write it like this. Okay, do you guys see any patterns maybe with this answer and what we started with? For instance, if I gave you y equals, say, 3 to the x power, what do you think the derivative would be? Natural log of 2 times 3x? 3 to the x power? Yeah, it's going to be something like that. Okay. The only difference is, let's say we put more in the exponent, more in the x, you multiply by the derivative of the exponent, right? Using your chain rule. Okay. Now, this is going to be a pattern. This is going to be a rule that we're going to work with. But we developed it just in case you forgot your rule. Okay. If you're working with exponents, remember, logs are your friends, especially natural logs are your friends. They help you get that x out of the exponent so you can find the derivative. Okay? Well, how about logs? Remember before we've talked about a log is just another way to write an exponent, correct? Well, I don't know how to find the derivative of log base 9, but I do know how to find derivatives of exponents. So let's convert this to an exponent. So this would be 9 to the y power equals 2x, correct? 9 to the y power equals 2x. Now, just like before, we have a variable in the exponent. Let's take the natural log of both sides. Natural log. And let's use the advanced move. Let's bring that y down in front because we've done this before a couple times. Natural log of 2x. This derivative is not too bad. You need a chain rule, obviously, right? Let's find the derivative. With respect to x, so natural log of 9, that's a constant, times y. So we have natural log of 9 would be the derivative times dy dx equals the derivative of this. Let's see here. The derivative of natural log function, because there's something else in here, not just a constant, right? It's not just a constant. Something else also. There's an x in here. It's be what? 1 over 2x times 2. Okay, solve for dy dx means multiply by natural log of, or divide by natural log of 9. So the derivative then, okay, those 2's cancel, right? So we'd have, what do we have? 1 over natural log of 9 times x. Now for fun, I'm going to write this again though, but I'm going to leave that 2. 2 over natural log 9 and then times 2x. Let's say I did not cancel those 2's. Do you guys see a pattern a little bit then with where the number placements are now? Okay, let's say we had y equals log base 8 of 3x. What would dy dx be? Okay, how do we get this 2? Where did that 2 come from? That was the derivative of the inner function, right? That's the dx part, or the du part, I should say. What is this? This is the argument of the log. What is this? That's the base of the log. Okay, so what would our derivative be? There we go. That's all it'll be. Okay, we can memorize this pattern, or we can remember a log is an exponent. We can use natural logs to get the variable out of the exponent and then just find the derivative of the natural log function. Okay, and here are those patterns. Okay, derivatives for any base other than e. We call that base a most of the time. So derivative of a to the x power is the natural log of a times a to the x. The derivative of log base a of x equals 1 over the natural log of a times x. Now, obviously, if we had another function in the exponent or the argument of the log, right, we would multiply by the derivative of that function also. There's a definite pattern here. Works all the time. Memorize the pattern. Or again, remember there's one way we can just muscle our way through it. The memorization of these patterns, these rules, will help you do the calculus a lot quicker. All right, let's take a look at this problem. I'm going to show you 2 ways to do this problem. The reason why I'm going to show you 2 ways is because there's, basically 2 answers. But first way, well, look at this. We say, okay, what type of function is this? What type of equation in this? What's going on? Inspect this and then choose your rules appropriately or find the derivative. Okay, so dy dx then. Okay, this is a base a, right? This is an a to the u problem, right? So if I look at my rules, a to the u would be natural log of the base times the exponent itself times the derivative of the power, right? So natural log of the base, ln of 2, times the exponential thing itself, 2 to the 3x, times the derivative of the power, which is 3. Okay, now reorganizing and simplifying this is going to be important. Okay, the 3 can go all the way in front. Natural log of 2, 2 to the 3x. And then remember, when we have a constant multiplier in front of a natural log function, we can make that the power. Natural log of 2 cubed times 2 to the 3x. And then what? 2 cubed is 8. Now this could be one of those problems where they have like E, none of the above, and you have something that looks like this, but the answer is actually something else. How else could we write this problem, do you think? Well, think about this right here. 2 to the 3x power is equal to 2 to the third times 2 to the x power, right? Or no? Back up. 2 to the third to the x power. There we go. We're multiplying right here. Okay, 2 to the third is 8, right? So this could be natural log of 8 times 8 to the x. It could look something like that. Okay, so let's keep that in mind when you have that product in your powers. You could raise your powers like that, stack them up, and then simplify your constants. One way to avoid some of this mess is identify that at the very beginning. At the very, very beginning, I could have said 2 to the 3x power. Well, I know that's 2 to the third to the x. I know that's 8 to the x power. So essentially, I just have 8 to the x power, right? This is an 8 to the x power now problem. So then dy dx equals natural log 8 times 8 to the x power. Natural log of the base times the exponential function itself. Okay? Questions on that at all? It's not really math trickery, but recognizing what's going on and simplifying as best you can, as quickly as you can, helps with some of this process. Okay, so definitely I would rewrite at the beginning if you could. All right. Let's find the derivative of a log now. Log base 10. And remember, I could have wrote this just as log cosine x, right? And that'd be the common log, which you have to understand that's the log base 10, okay? And I'm going to write that down just so maybe we can put that in our notes, just to remind ourselves. Sometimes writing it down reminds ourselves that this is the common log, that's log base 10. Okay, you guys remember the pattern? Have it memorized already? Ooh, this is tough. Okay, dy dx equals. All right, here's the log. Its base is 10. Its argument is cosine. So this would be log base a of u, right? How did that go? Was that 1 over natural log of the base times the stuff? For some reason I was thinking of a sign. Times the stuff times the derivative of the stuff, negative sine x. All right, that'd be what, negative sine x over natural log of 10. Those are together, can't take them apart, times cosine x. And they are probably not going to have that as an answer. Well, sine over cosine, that's tangent, right? That'd be negative tangent over natural log 10. All right, if you memorize the pattern, it's much easier. It's a lot quicker, okay? Let's say we forgot the pattern. You had one of those old crap moments during the AP test, or when you're doing your homework, you can't memorize, you don't remember the pattern. Well, remember, a log is an exponential function. Convert it to an exponent. 10 to the y power equals cosine x. We are always going to take the natural log of these problems and then differentiate. Y natural log 10 equals natural log cosine x. You could take the derivative then. And the reason why I'm going over this, because sometimes we're going through AP tests, that's 4 hours of madness, right? You got to have the processes down. Okay, this is a constant, natural log 10 times dy dx. Okay, the derivative of natural log cosine x, that would be 1 over the stuff, times the derivative of the stuff. Well, negative sine over cosine, that's negative tangent, divided by natural log 10. Okay, so obviously we're getting the same answer. I've had students in the past that didn't want to memorize this. They went straight to an exponent, took the natural log of both sides, did it this way every single time. It's up to you guys, which way you want to do it. You're going to get the same answer in the end anyways. Okay, obviously this is a to the x dx. This would definitely work with a to the u du, okay, if we had to make a u substitution. But the goal here, guys, is we have to get a base to an x or a u power. A base by itself to a u or x power. All right, let's find the antiderivative of 2 to the x power. Again, this could be 2 to the u, 2 to the whatever, right? We can make a u substitution. I don't think it gets much easier than this, guys. Not at all. Okay, the base is 2, so that's our a. So 1 over natural log, what am I doing? 1 over natural log of 2 times 2 to the x plus c. Sometimes we'll write it as 2 to the x over natural log 2. Either way,